Hello everybody. I've got some great news. Essentially, our paper about the solution to the boundary problem has just been published in Frontiers, and you can read it, download it. I recommend if you have a difficulty just going through an entire paper, you can, get the PDF and read it in a long flight, or even, you can put in one of those text to speech, apps that will allow you to essentially, just kind of like open a glass of wine. Warning, ethyl alcohol is an addictive carcinogenic neurotoxin. Be careful. And just chill and relax and essentially, listen to the paper as you relax while drinking a glass of Pinot Noir or something like that. Yeah, just enjoy it. I think it came out really well. I've got to thank Chris Percy, who's been an amazing collaborator for QRI. I and everybody else in the team is just very grateful that he's joined forces. Essentially, he's been an amazing force multiplier. So yeah, just so much gratitude. Thank you so much. It's been incredible working with him. He has just a incredible capacity to kind of just go through the literature and be very comprehensive and formulate very precise arguments. So extraordinary work. So I'm gonna essentially do primarily two things in this video. The first is just kind of like walk you through a little bit of my personal kind of like journey for understanding the boundary problem of consciousness and why it is relevant, how I came to that as a research priority in a way. And then also just like walk you through the paper. Just kind of like give you a sense of like, what is it that we are saying? Why do I think this is actually a significant, meaningful, non-trivial, novel contribution to the field of consciousness, both literally and figuratively. But before I do that, I'm actually going to share the query of the day, which is a Vibe Camp recorder. Essentially, these are the stickers. Thanks, Hunter, at Aqualia Computing on Twitter, for making the stickers. So essentially, I have been very busy recently. It's why, you haven't seen many videos from me as of late. Honestly, I feel very grateful because I am doing exactly what I think I should be doing right now. Really pushing through in the most promising direction with resources and the help of wonderful people. So, a few months ago, I started doing very serious, rigorous consciousness research that is not public yet. Mark my words, in 6 months, we're going to give you a very big delivery of information and hopefully publishing some findings. I think they're going to be paradigm shifting. Not to brag, but honestly, we're doing very mind-blowing consciousness research, and we will continue to do so. But along the way, also, I've just been traveling a lot. So recently, I went to Vibe Camp, then the psychedelic science, huge conference by MAPS in Denver. Then I went to Oregon to visit friends, and then afterwards, I just went to Costa Rica for the Lionheart Summit, which is a venture capital that essentially is trying to figure out how to provide funding for consciousness research and AI safety initiatives in a way that is synergistic with essentially kind of startups and nonprofits. And it was a whole thing. It was a fabulous meeting. I got to hang out with Forrest Landry and Anders Sandberg and Daniel Ingram and Shenzhen Young. And, it's been a busy, pretty fun, satisfying last 4 months or something like that. But at Vibe Camp, let me tell you a little bit about Vibe Camp. Vibe Camp, there is the myth that it doesn't exist. It's just a big conspiracy of Twitter people to pretend that they're gathering. But no, essentially, it turns out that there is a kind of like a fairly large, maybe like several thousand, people, maybe up to 10,000 people. That would be like stretching it, but essentially community on Twitter of people who essentially kind of like come from various worlds that are converging. Of course, there is people who we've brought from Qualia Research, kind of like getting into that community through us, but, Slate Star Codex, effective altruism, meditation circles, psychedelic circles, internal family systems, all of that kind of like congeals. And there's like, these pretty wholesome community of people with ADHD. The first approximation. But okay, so like Brooke, one of the core people in that community, decided to essentially get everybody the opportunity to meet in person. So last year they did the first one. I did not go, but it turned out it was a big success. And this year they repeated it and they made it twice as large. So they actually had like 800 tickets. I think like about like 650 people actually attended. And it was very beautiful. My contribution to it, in addition to, I guess, spreading the gospel of Qualia Research Institute and the computational significance of consciousness, which I will do anyway. I essentially, made this perfume. The main idea of it was, it's called VibeCamp Recorder. The main idea of it is, hey, let's make something that essentially will create an impression in you. It's thematic, it smells good, but above all, is very unusual and weird so that you have never smelled anything like it. And the main olfactory idea, as I call that, is kind of like a smoky rose, but decorated with other things. In particular, kind of like vanilla elements, citrusy elements, key lime, fenugreek. Fenugreek is a very core component of it. Now, if you were to ask a perfumist, okay, like what does this smell like, or what is the main idea of it? Actually, they might say something like galaxolide. It's the sort of thing like if you know, you know. But it's kind of a esoteric perfumery. This is very, a lot of the composition is based around galaxolide, because galaxolide is a beautiful musk that essentially binds together many olfactory features, which is kind of a segue into the binding problem / boundary problem. How do you put together a lot of phenomenal qualities into a unified experience? And galaxolide does that, because otherwise, if these didn't have galaxolide, or it had like a different musk for this particular combination, you would have like this effect where like incompatible scents would kind of like flicker. For example, vanilla and key lime. If you just mix them neat, you're gonna get kind of like this like flickering between like the sour and sweet and vanilla, kind of like fading in and out. But if you add galaxolide to the mix, you get this beautiful kind of like orange creamsicle envelope where like they blend and they're like actually unified. So it's fascinating. A lot of people really enjoyed this scent to such an extent actually that I am considering including it in the next year's scent offering as a fundraiser. It is not as carefully optimized, and I would say not as beautiful as Hedonium Shockwave, which, this one I put a lot of effort into finely tuning. VibeCamp Recorder is still quite finely tuned, but it's more like a fun, playful idea rather than like, the result of an optimization process, essentially. As the term Hedonium Shockwave would suggest. So I might include it. I will say that, even though it's been so satisfying to actually share the scents that I've worked and designed, you can see, okay, those are a few boxes of all of the perfume ingredients that I have. You have like so much more. I've explored it quite extensively. It is very satisfying because when you actually share something you've worked on that is like so difficult to describe, the quality of a scent, especially an unusual scent, is very satisfying when you hear people's reactions, whether they like it or not. Just kind of like, hey, how are you reacting to these? What is evoking in you? But the truth is that it is a very time-consuming endeavor, especially the kind of like packaging them and mailing them and all of that. But we're actually considering, kind of like in a contractor basis, getting somebody to take that work off of me, where essentially I would be, producing the main formula, but not using that much time in kind of like actually distributing it. All right, so the binding / boundary problem. So a little bit of a personal history, I suppose. It's I've been obsessed with the problem of consciousness since I was 16. I mean, I've been thinking about it since I was like something like 7 years old, but I didn't realize how significant consciousness was and how poorly understood it was until I turned 16. I had a weird ego death experience with marijuana, it turns out. I've told this story before, essentially, but yeah, that just like made me realize, oh my God, we do not understand consciousness. I had no idea that the mystery was so wide and deep. But, you know, it's something that takes time to mature. You know, I've been obsessively thinking about it, but still the way I think about it has evolved tremendously over the years. You know, now I'm like 32, so like about half of my life I've been really obsessively thinking about this. And there's like phases, there's like stages throughout my life for like how I used to approach this problem, you know, in different levels of maturation for how I used to think about this. And I've got to say that the binding boundary problem just didn't figure as kind of like the most significant thing, or even as something to study specifically. You know, when I used to think about consciousness at the age of 16 or 17, it was more about, the question of like a first-person perspective. How do you get a first-person perspective in a otherwise third-person universe? And I was curious about qualia, but also I wasn't thinking that deeply about qualia or you know, the palette problem, you know, the state space of qualia or something like that. That came later when I started to formalize this problem and talking to collaborators and reading the literature. And then, okay, yes, actually we can break down the problem of consciousness into sub-problems. And I definitely credit David Pearce around 2011 when I met him at Stanford and then developed a great friendship with him, that he was essentially saying, hey, my friend, you know, your computational theories of consciousness, and I was a computationalist, a hardcore computationalist. I just thought about causal structures. I just thought about information processing as the source of consciousness. But yeah, essentially he pointed out like, well, okay, but how do you know, draw a boundary around a bundle of information and say, okay, this is your experience as you know, distinct from everybody else's experiences, or as distinct from like the space around you, or like this bundle of air around here. And essentially, yeah, David Pearce, through a lot of conversation, eventually convinced me that this problem actually may rule out a whole class of theories of consciousness. Functionalism, causal theories, computational theories of consciousness. They seem inadequate for making sense of the binding problem. Later on, actually, with my co-founder of QRI, ex-collaborator, we did a lot of work together, especially around like between 2016 and 2019. Really solid, amazing collaboration back then. Yeah, I mean, essentially, he gave me kind of like a couple pieces of the puzzle that I took very seriously and incorporated into how I think about it, including, well, qualia formalism, which he coined in Principia Qualia, essentially the idea that for every, you know, system that produces a conscious experience, they correspond a mathematical object such that the properties of the experience are isomorphic to the mathematical properties of that object. That was a very important way of thinking about it, right? The kind of solution that you will get, you know, for a theory of consciousness will actually be a way to look at systems and interpret them in order to get a mathematical object out of it. And then, you know, some kind of ability to read the mathematical properties of that object and transform them into the phenomenology of the experience. But then also, you know, two other things I definitely credit him with, in addition to a whole lot of other things, which, yeah, have been important in my development, is that, yeah, he pointed out that maybe a more fruitful, more tractable way of talking about the binding problem, again, how, you know, 100 billion neurons distributed in the brain can simultaneously contribute to a unified experience. Instead of thinking about it that way, maybe you start out with kind of like a fundamental universal unity of everything, you know, the quantum field or like, you know, 0-point energy, whatever it may be. You just kind of like, you start out with an ontology that is unified. And then the question becomes, how do you draw boundaries in it? And in particular, a very important hint that I first heard from him, although, you know, it's been talked about in the literature, as we will discuss briefly, was, frame-invariance. That, like, ideally you will want a solution to consciousness, you know, and solution to consciousness becomes how do you interpret a physical system in order to get a mathematical object that is isomorphic to your experience. So how do you get a solution to consciousness such that it is frame-invariant? Where like that it does not depend on who is the observer, how fast it's moving, from where it is measuring, if it is actually, describing the system, the physical system, in a way that is frame invariant, right? Like it needs to be frame invariant so that it doesn't depend on like, well, if you look at it this way, it is consciousness. If you look at it in that way, it is not. That would seem, an absolutely essential constraint. Well, importantly, after thinking about it in those terms, one kind of like very simple way of describing kind of like this transition is realizing that if you live in an ontology, implicitly, if you believe that the universe is made of atoms and forces, the binding problem is actually impossible to solve because there's no frame invariant way of describing a boundary around it. It depends on how fast you're moving, from what point of view you're analyzing it. And also, I mean, that also goes for like, information or causal or, integration theories of consciousness that also, they're not going to be frame invariant if you have an ontology of atoms and forces. But the universe is not made of atoms and forces. And we know these since like the 19th century. That was one of the very big insights of Maxwell and Faraday. Like how they started to think about electromagnetism was, no, these are not just particles and forces. Actually, these are fields. And the way the field evolves is according to differential equations that essentially are coupled together. And so in a way, like matter tells how the field should be shaped, and then the shape of the field tells how to move, how matter should move. These like interrelationship between the two. And in some sense, you can even think of particles as field properties. Like kind of like one mind-blowing conceptual reframe that you can do, which is very helpful, is to think of electrons rather than particles that are, kind of like emitting forces, an ontology that doesn't allow you to solve these kind of problems. Instead, you think of an electron as actually a place in the field where field lines converge, right? So it's almost the electron is a manifestation of the field rather than something that is inherently existing. Also, yeah, some Buddhist intuitions there, kind of like emptiness or dependent origination, right? Like the electron doesn't exist with the surrounding field because actually it is a property of the field. It's not a self-existing, independent, metaphysically enduring object or anything of the sort. Now, if you have a field ontology, the universe is made of fields, then the question is, how do you get boundaries around those fields in order to explain why I'm here and why you're there? And yeah, the third kind of like, personal, very important piece of the puzzle, I would say for me was encountering Stephen Lehar, because, in his whole framework of, harmonic resonance as a conceptual analytic tool to make sense of holistic information processing in consciousness, in particular things such as the interpretation of visual gestalts or like sensory gestalts, they have like a kind of holism, a life of their own. They act as units, they behave as individuals. He proposed essentially that, the binding between these features happens via resonance. Why? Well, essentially, he was criticizing the neuron doctrine, where essentially just thinks as the unit of information processing in the brain as kind of neurons, and you can maybe discretize, you can think of your brain as a big graph, essentially. And the problem there is that, well, binding there would be essentially metaphorical. Would be, well, there is some kind of tag that says, this feature over here, this edge and this color, let's say blue, they belong to the same object. They're tagged as being part of the same object. But just because two things are tagged, they're not necessarily integrated, right? Like, in fact, the whole idea of binding is that it is actually some kind of glue. So that if you move, part A that is bound to part B, automatically by moving A, B will also be moved, like an actual glue. And essentially what Lehar was arguing in many of his canonical papers is that binding must be a kind of glue, and he suspects that resonance is that glue, because resonance actually gives you this capacity of, essentially affecting at a distance. You're not breaking the speed of light or anything of the sort. You're still constrained by the speed of wave propagation in the medium, of course. But, taking that into account, there is nonetheless holistic behavior. When two things are like tightly coupled in resonance, moving one will move the other, of course, with a little bit of a delay. But, for many purposes, actually, that doesn't matter. Functionally, it still is usable. And so now Lehar was thinking about the binding problem in terms of local binding, which is how features of your experience get put together into unified percepts, he did not, as far as I know, ever provide a solution to the global binding problem. Essentially, how do you draw this boundary? Essentially, every piece of your experience that are connected to each other, how is it that they're not connected with things outside of your experience? And as far as I know, Lehart doesn't have an answer to that. But resonance as a solution to the local binding, I thought was a very important hint and clue. And that was, all of those pieces of the puzzle, I was already thinking about them around 2017 or so. And one of the ways in which I think you can make tractable progress in questions such as, philosophy of mind and consciousness, very deep philosophical problems that may actually have real, solutions that eventually become science, is you have to keep in mind the constraints that such a theory must be able to satisfy. And so already by then, 2017, I was thinking, okay, like all of these pieces of the puzzle are generating constraints that a theory of consciousness must satisfy. And in particular, the boundary problem. So what are these constraints? And then I kind of like formalized it and thought, well, okay, my desiderata, or explain that the thing that a theory must be able to satisfy to be a solution for the boundary problem, according to me, putting all of these things together would be a frame invariance. Okay, like again, it doesn't depend on your particular point of view or how fast you're moving, and so on. Second is no strong emergence. This is kind of like the tenets of physicalism as defined by David Pearce, where essentially you say that the universe behaves according to the laws of physics, even if you're silent about what it is, what fundamentally the universe is. You're just saying that it behaves according to the laws of physics. Spoiler, it is a gigantic field of consciousness. But essentially, no strong emergence is entailed by physicalism. There's nowhere in the universe, all of a sudden, quantum field theory doesn't work, right? Like all of the strange, bizarre things, whether it's like superfluid helium and superconductivity, super radiance, I don't know black holes, but like weird things like neutron stars and so on. They are, accounted for by quantum field theory. Is just that they're like, kind of exotic high energy configurations of it, or like very low energy configurations of it, where very different things happen. Nonetheless, there's no strong emergence, right? It isn't the case that, when these conditions are met, a new law of physics gets activated. No, we don't want that, right? Like we just want standard physics in a way. So that's number two, no strong emergence. Then no non-epiphenomenalism. Unfortunately, this is a very, very confusing thing, but essentially what you want is to be able to explain not only why we're conscious in these vaguely defined sense. You want to explain why are the boundaries around experience where they are, such that actually our experience kind of makes sense. We can talk about our experience. We have the capacity to introspect and share it with others. How did that evolve? How did natural selection use and see the proper, the boundary condition of a moment of experience? How is it using it? How is it causally significant? If you just have a way of interpreting these mathematical objects where you say, hey, when such and such conditions are met, you get a boundary, but then the boundary doesn't have any further effects as a whole, then that's not going to be a solution, right? Because evolution would not be able to see it, would not be able to recruit it for information processing or for causal effects, right? So avoiding epiphenomenalism, not of reality or consciousness as a whole, but in particular epiphenomenalism of things such as feature binding or boundary making. Yes, that makes a lot of sense. It's absolutely essential. You have to keep that as a constraint in your mind. And then, to conclude, the fourth one would essentially be that, essentially you have to explain this in terms of something like weak emergence, or weak downward causation. Otherwise, you're going to be going against the laws of physics and probably not be right. I think around that time, I was actually, those constraints were bouncing in my head. I was thinking about it constantly. And it was in the middle of a conversation at a restaurant. I remember quite suddenly, my mind generated this picture of field lines forming a loop and enclosing energy in the brain. And then I realized if that happens, then waves will bounce off the edges and the whole thing will kind of start to act as a unit. And maybe that is why the boundary is significant. Because when the waves are trapped and they're bouncing and you get the resonant modes of it, then all of a sudden you have holistic behavior, have something that has the capacity to act as a unit, can be interacted with as a unit, and can play the role of integrated information. But fundamentally, ontologically, the reason why this would be a unit would not be because of its causality, would not be because it's integrated information. It is because fundamentally, there's actually a boundary in the bottom layer of reality, or at least that was the idea. And then, yeah, it was, just remember it very clearly, you know, after that dinner, it was like, hold on a second, did I just get the solution to the boundary problem? Does that, But I kept thinking about it, and yeah, around 2019, submitted an abstract to the Science of Consciousness conference for these. Unfortunately, I didn't go because COVID in 2020, right? So, oh well. But essentially, they're already kind of provided like, yeah, this set of like constraints that any theory had to meet. And actually, I wasn't focused in the electromagnetic field. The paper that we published just now is essentially the hypothesis is that the boundary problem gets solved in terms of topological boundaries in the electromagnetic field. You know, maybe something else that actually may be topological boundaries in, you know, the strong force, in the electron field or something like the strong force or some other, or maybe in quantum field theory. Like, I don't know, but that's low-hanging fruit with potential empirically testable predictions is, yeah, electromagnetism. But yeah, back then I wasn't being so specific. It was still like more abstract, just making the case for topology. But yeah, so that's a little bit of the history. And, you know, I've made videos and written articles about this, but like finally it's in academia. And on top of that, it is novel, it is new, and it is filling a hole that we found in the literature as well, right? It is not only that like, hey, I think this has explanatory power. It is actually much more interestingly along the lines of, hey, a lot of researchers have been wondering, is there a, you know, possible solution that satisfies all of these constraints? And we're saying, yes, actually this satisfies all of these constraints, and it is what people have been waiting for. What people have been waiting for! You've got it! Okay, so some literature review. You know, Chalmers in 2016, well, 2013 actually, the combination problem for panpsychism. Yeah, he kind of like raises actually this question of binding quiddities. Hey, like if you have something that solves the binding problem in panpsychism, it has to be something that actually has causal effects. And it makes sense why it has causal effects. It's not an additional law of physics or something like that. But in particular, you know, he attributes the boundary problem, formulation of the boundary problem to Rosengard, 1998, that essentially he wrote this, yeah, pretty amazing piece called The Boundary Problem for Phenomenal Individuals. And I love that title because it's so ambiguous. You know, it actually could be something like you find in a Cosmo, or like, you know, like one of these like cheap fashion magazines or something, or personal development magazines saying like, if you are a phenomenal individual, how do you keep boundaries with other people? You know, how do you avoid yourself being exploited? How do you avoid difficult breakups or something like that? You've got to keep good boundaries if you're a phenomenal individual. Well, of course, I'm joking. Down the line, actually, in 2004, he published essentially a very similar piece, now named The Boundary Problem for Experiencing Subjects, which I guess removes a lot of the ambiguity. So it's not a Cosmo magazine. It's not a Cosmo article anymore. But yeah, no, Rosenberg, essentially we found, yeah, he was the first one to kind of like very clearly articulate like the difficulties with the boundary problem and like what is it that a solution would need to satisfy. So in particular, you know, it's talked about as kind of like, well, a lot of people think of the brain as kind of just so highly interconnected that there's kind of these like peaks of integration and interconnectivity. But like how is that not a fuzzy relationship, right? Like, yes, if there's a network of interactions and there's maybe some clustering and like, hey, this is tightly clustered, kind of like in causal interactions in the brain, for example. Well, yeah, but there's still edges that are connecting it to the rest of the network. It's not like you actually have like a fundamental boundary there arising. So how do you get my experience versus your experience, right? And it's fuzzy, right? Like kind of these like clustering approaches is kind of fuzzy. Thresholds, thresholdings for like, hey, the modularity of the graph or something, of the causal graph, like that will also be pretty arbitrary. Like why that threshold and not something else? And there's going to be, some kind of like mechanistic motivation, right? Like the binding or the boundary making has to be useful for something, right? It has to be meaningful. It has to have causal effects. Otherwise, it's just epiphenomenal, right? It's just something that an external observer looking at the system will say, oh, I kind of look like there's some kind of boundary around here, but no, it has to actually have significant causal effects. And so, like the way in which, he kind of like formulated it was how consciousness can exist at the middle level. Like this classic, I guess, like Greek, between Celia and Charybdis, these like two terrible monsters, and you have to navigate just exactly in between. Yeah, kind of like the unity of experience at the meso level, at the human level, is very mysterious, right? Like, why is the unity of experience not at the microscopic or atomic level? And why is it not, for example, at the level of galaxies, right? Like, we have trillions of cells, right? Like, why is the unity of consciousness not there? Why isn't it like, at the organ level? Why isn't it at, the group level, at the family level, at the society level, or at the ecosystem level, right? Like, why exactly you as an individual? That is how he formulated it. Very worth pointing out that Schrödinger, the famous Schrödinger from the Schrödinger equation, he also, he was a philosopher too, and very deeply motivated to answer the big questions about consciousness. In particular, actually, he was an open individualist. Schrödinger actually believed that we were all one consciousness, just as Einstein. Einstein also believed in open individualism. But interestingly, unlike Einstein, for whom there is no evidence that he ever actually contemplated the boundary problem, I wish he did. Would have been very significant, I think. But Schrödinger did. Schrödinger was exactly asking the question, why is the kind of like the boundary around us at this level rather than the cell, organ, system, culture, ecosystem? Why at the human meso level? And so, it's kind of like the boundary problem is like we have to navigate these, the cilia of like tiny subsystems being bound all the way to the Charybdis of why is the galaxy not the level at which everything gets integrated, or the whole universe for that matter, the entire quantum wave function for that matter. Now, again, I've got a Chris to thank for this, but essentially very, very exhaustive literature review to try to see if anybody had formulated anything similar. There is one researcher who has talked about, potentially topology, which is Robert Predner. Actually, he was, interestingly, my TA back at Stanford for a course in philosophy of mind. But independently here, I have that kind of like topology potentially being significant. But he was thinking of it in something like topology of a graph, for example, as opposed to the topology of a field, which is how we are providing a contribution here. But essentially we searched in the Scopus database, just with so many possible keywords, anything that might potentially have any relevance to the boundary problem. And it turns out there were really only 3 publications. One is by Frekete in 2016, which was actually restricted to computational theories of consciousness, but nonetheless, he was kind of like thinking about how could there be a graded measure for an observer-independent, partition within a computational theory of consciousness. And essentially, he was finding, some problems of like, how do you avoid not having just epiphenomenal appendages? If the measure says like, hey, it integrates at this level, and you were to just consider one of the subsystems, and the measure now says it integrates at this level, how is that level being actually swallowed up by the larger one, right? Like you have some issues about mirror logical nihilism or like a part-whole relation ambiguity that makes it actually very observer dependent and not frame invariant. And yeah, as far as I know, all computational theories of consciousness suffer from this. I don't know one that actually that has an answer to that. So you don't even need to do something like the slicing problem, which is the other paper we published with Chris. To realize the problems with the computational theories of consciousness. And I say this as somebody who was a true believer in computational theories of consciousness until David Pearce disabused me of of that. But yeah, the other two significant publications are by Tam Hunt, who him and his team is essentially developing this thing that is called GRT, their general resonance theory. And their theory here is that the boundary is constructed out of the lowest shared resonance in a system. And they argue that that actually does essentially partition the universe into clusters. And so creates a very natural way of segmenting energy in the universe, and therefore ways of getting actual boundaries. However, I would say there is a bit of a problem here, which is that resonance is a graded process. It's not the case that let's say like two waves over here, you can clearly say where the resonance ends. Like, okay, sure, like these two peaks and troughs are going in synchrony, but like as you approach kind of the outer edges, at what point are you saying that the waves first of all, that the waves actually belong to that particular vibrational mode, especially in a nonlinear system where there's a coupling between resonant modes? I'm very, very unclear about that. And then spatially, where does the resonance end? So as I see it, general resonance theory, although we applaud absolutely the effort to make it quantitative and mathematical and precise, I am not convinced that it actually creates objective boundaries. And especially that those objective boundaries, as opposed to the fuzzy boundaries, are in any way causally significant. But, there might be ways around it, in particular around the topic of phase transitions. If in physics, there were some way of saying exactly where a phase transition happens, and also that gives rise emergently to a lowest shared resonance, then yeah, actually that might potentially be a solution to the boundary problem. Now, as you will see in a bit, as I essentially give you a better formalization and breakdown of the boundary problem, essentially we think that, yeah, there are other theories for the boundary problem that are promising. However, currently in the literature, other than our formulation and Rosengard being kind of the president of this, there isn't yet, or there hasn't been yet until now, this kind of like breakdown of the problem of the boundary problem in a way that we think would be satisfying. In that, like, yeah, some solutions to the boundary problem can tackle some of these, sub-problems or desiderata, but not all of them. So we claim that ours actually tackles all of them, which is what makes it so promising. There's also like a lot of indirect discussions. For example, one of the things that I read, I guess 2016 must have been, is like this book called The Unity of Consciousness by Tim Bain. And I really appreciate kind of like trying to be comprehensive, and the prose is pretty excellent. I mean, it's very well written and covers a lot of ground, but it doesn't actually address the boundary problem. It wasn't until I think like a reviewer of his for another paper essentially was saying like, hey, okay, yeah, but yeah, sure, you're providing some ideas for how to solve the binding problem, but then how do you stop that binding from essentially propagating to the rest of the universe? And essentially, yeah, he was trying to reformulate it and say like, why? Okay, so maybe Bain's formulation of the boundary problem is why particular experiences are part of the experiences they are a part of, whereas others are not. Actually, I think it is very helpful to share many formulations for the problem, because some may like, spark a resonance in you that maybe others don't, right? So I'm not going to say like, hey, this formulation is the one and only. I think, for something as complex and intricate as philosophy of mind, actually having various approaches, various definitions is very helpful, because At the end of the day, a lot of the progress depends on you actually being convinced that there is a problem, right? So just to say it again, the way Bain would essentially formulate it is why particular experiences are part of the experiences that they are part of, whereas others are not. There's a bit of an issue here, which is like, you're kind of saying like, why an experience, and I take it that actually he means like features of experience. For example, like why these like speck of, I don't know, the color of my hand, how is that bound? How is that part of the experience of your visual field? However, with holism, where you actually say like, no, the experience happens all at once. In some very deep ontological sense, there are no parts of an experience. An experience is not made of like smaller experiences. An experience is just a whole thing. It's just a whole thing that its intentional content, its internal information structure is precisely the feeling that there are parts. Let that sink in, right? Like that's also mind-blowing actually, that like in some sense your experience has no parts, but the information content that your experience is rendering is that of an experience with parts. But the parts are actually kind of illusory because actually your whole experience happens all at once. Yeah, it's mind-blowing. give that a little bit of thought at some point. But essentially, yeah, that is the issue with kind of a Bain's formulation here. And we prefer, Rosenberg's more formal way of putting it, which is why some experiences are contained within a given phenomenal boundary. Like, okay, now you don't have these like part whole ambiguity, or you're not going to have to talk about mere logical nihilism. You're just saying why some experiences are contained within a given phenomenal boundary. We think like, that actually gives you a little bit more traction. Then, part 2.4 of the paper is, essentially talking about EM field theory, electromagnetic field theories of consciousness, and do they address the boundary problem? Here is the thing. You will see this all over the place. I have been saying electromagnetic theories of consciousness will very proudly proclaim, we don't have the binding problem because the field is unified, is a non-issue for us. Which is, all well and good. But then you get the boundary problem. So what are you gonna do, right? You solved one problem, but now you got a different problem. So we're gonna tone that pride a little bit. It's like, no, actually, just because the field is maybe unified and smooth and so on, doesn't mean you actually solved everything. You just switched to a different problem. So a few interesting things. Like, for example, there's like some field realist theories of electromagnetic theories of consciousness, like Jones 2010, 2019, where essentially, it's called a field realism, where the energy of the field is actually the carrier of consciousness, the amount of consciousness. I'm actually very sympathetic to it, as like, energy doesn't get destroyed or produced, it just changes form. So like, maybe it's very appealing to think that the total, consciousness in the universe is essentially maintained, is just being in a state of flux, which is different than, for example, McFadden, who's like one of the main proponents of electromagnetic theories of consciousness, who actually thinks of the thing that corresponds to consciousness is the information in electromagnetic field. Jones 2013, just to kind of like keep moving on here, is essentially that he would say, well, no, only sufficiently strong electromagnetic interactions can essentially solve the binding problem in this context. And well, maybe that might give you an explanation for why two individuals don't share the same experience. But hey, it doesn't actually address kind of like the deeper problem, which is like, within your brain, how do you determine which subsystems are actually contributing to a moment of experience? Because if everything actually has a strong field within the brain, like where do you find the boundaries, and are they precise, right? Like, one thing is to say, hey, I have a solution for like why you and I are not the same experience right now, but that is not enough, because you also have to be able to say, if you look at an active brain, where are the boundaries there, right? Like is it because it ends at the skull? Is it because of, well, actually that takes me to one of the solutions by McFadden, which is the cerebrospinal fluid's degree of conductivity might work as a Faraday cage, which is a very interesting possibility. But that also, I mean, it doesn't really give you a solution to the boundary problem either, because what is actually the boundary between the cerebrospinal fluid and other parts of the anatomy, where you would actually say precisely here at fundamental reality level, you actually get this boundary. It is actually pretty fuzzy. And then it opens up the possibility of like very fascinating thought experiments where, for example, you slowly open up, make a hole through your skull, and you kind of like dry out the cerebrospinal fluid. And, you actually start getting kind of this the limit of diffraction, and you start having electromagnetic waves starting to leak. It seems to me that also has kind of this fuzziness property that like, hey, there's no precise moment where you can say, now actually you have like a fully enclosed electromagnetic field. If he's right, actually that would in principle allow us in the far future or medium future, I don't know, in a few centuries maybe, to actually like mind meld with others. If you create a dry channel that doesn't have the cerebrospinal fluid, and essentially you now create a Faraday cage around the two brains, they sharing the same field within the two. Okay, like that's an interesting possibility. And Shane and Kepler in 2018, one of the trippiest papers that we reviewed, has to do, this is more of a quantum thing, but it is electromagnetic insofar as they're talking about the electron field, in particular, coherence patches within the electron field, and they also talk about 0-point energy, and they're talking about essentially how in the quantum vacuum there are patches of coherence that are like clearly delimited, and that actual moments of experiences are like that. Just to name a few others, Winters 2021 talks about like temporally integrated causality. That may actually solve the binding problem, but it doesn't solve the boundary problem, because actually the causality would, I actually talked about this in my previous video about solving the boundary problem. Integrated causality doesn't really solve the boundary problem, even if it gives you some binding problem pointers. Then like Bond 2023, very recent, is coherent fields within expanses of photonic waves. But there also you have an issue of kind of like a logic of, a fading with distance logic, where like the boundaries are not actually strict. So in other words, people have been trying to kind of like propose some solutions to the boundary problem, both directly and indirectly, and they are not really satisfying. So we went ahead and essentially broke down the boundary problem into sub-problems that we think are actually tractable, and formalizes the boundary problem. So number one is the first sub-problem of the boundary problem would be the hard boundary problem. Exactly as it sounds, we don't want fuzzy boundaries. We want absolute real boundaries that they're true and real independent of how you look at the system, and they're like 100% you belong inside or outside. That if you really think about kind of the binding problem in terms of, for example, transitivity, every two features of your experience are connected by the fact of being part of the same experience, right? So if A is bound to B, which is bound to C, that entails that A is bound to C. When you have like these fuzzy boundaries, you can actually make these chains, right? Like A is bound to B, which is bound to C, which is bound to D. But then A and D actually may be so weakly bound that you could say like, oh, they're not bound anymore. So fuzzy boundaries, I think you're really not thinking deeply about the properties of your consciousness, of the phenomena that you're trying to explain, right? You're kind of like maybe explaining something else, not really looking at the thing, as it were. The second one is the lower levels boundary problem. This is essentially kind of, the cilia. essentially the why isn't the boundary, for example, at the cellular level or at the neural cluster level? Like inside us, why are the partitions like smaller than, let's say, like the thalamus or the brain, or like whatever is actually the carrier of the internal world simulation of our environment? And you have to explain that, right? So there's kind of like a lower bound. You know, in mathematics, oftentimes when you want to find a value, you can say, well, there's a lower bound and an upper bound, and the work is in between. Exactly like that. Like the lower level boundary problem is like, why are the boundaries not at the smaller scale? And then at the higher level boundary problem, which is like problem number 3, or subproblem number 3, is why are the boundaries not at the higher level? And in particular, things such as like, hey, when we're in synchrony, singing in a choir, right? Or meditating together, why are we not all just one big field of experience when we do that, right? Like, why doesn't that happen? Now, you know, some people say it happens. Okay, so I think the parsimonious explanation actually is that when you have the feeling of telepathy with somebody else, for example, on LSD or like a deep meditation, it is because the internal boundaries of your world simulation are essentially getting softened or maybe even breaking down. So in some sense, it doesn't mean that you're literally merging with the rest of the universe. It just means that you're softening and reducing or eliminating internal boundaries via, let's say, a process of synchronization. Well, if that is the case, then yeah, you don't actually merge. You know, you're not one with the economy. You're not one with this person that you're having a deep connection with. You're just kind of like having this interesting synchronization between your internal representations of those other aspects of the world. But yeah, essentially any solution to the boundary problem will have to explain why the boundary stops at the level of the individual or the nervous system. And then like number 4 is, yeah, the private boundary problem or privacy boundary problem, which is why can't we essentially like merge with others, right? So it's kind of like, rather than talking about, hey, like scale, is more kind of like why aren't, for example, the boundaries transient, right? Like why is it the case that you have kind of this like enduring boundary for a given organism? And then number 5 is the temporal boundary problem. Actually, this one is very tricky and not many people realize this. This has a lot to do with philosophy of personal identity. You know, Parfit, Daniel Kolak, you know, and reductive theories of personal identity. For example, Derek Parfit in particular, you know, he had like this idea that the continuity of the self throughout time is illusory. Actually, there's just kind of like fragments of memory that are constantly recreating the illusion of the continuity of a self. That would be diachronic identity, like the identity over time. And, you know, that's in some sense, that's kind of like trivially true because you're not sharing the same experience as your past self. And you're not sharing the same experience as your future self. So there is actually something that is dividing you and creating a boundary between you now and you in the past and you in the future. That already kind of like, I think, like hints at the idea that you're not just one enduring metaphysical ego over time, right? Because you're not just one huge experience throughout all your life. You're like lots of different fragments, different moments of experience. Now, I would say, you know, speaking for myself, Derek Parfit, I affectionately call him Mr. Almost, because he always gets very close to the edge of a mind-blowing insight and just, he gets scared and takes a step back and just defaults to common sense. He does this all over and over in so many different contexts. Unfortunately, I'm sorry to say that. But yeah, I mean, in the case of binding, yeah, he realizes there is no actual kind of like binding across time, but he has no if you read Reasons and Persons from, you know, cover to cover, there is no discussion about the actual synchronic binding or the synchronic unity. The fact that, yeah, every moment of experience does have this kind of like natural boundary around it. And we can, I mean, I would argue that it's not illusory actually for very deep reasons. Even if our experience is less unified than it seems, the mere fact, you know, that you can have like a complex or like percept that even if it has just two features at once, you know, this color and this color, the fact that you can experience the contrast, that is already some kind of like fundamental unity of information in its presentation. Derek Parfit doesn't talk about that, doesn't realize that. My sense is that he actually never really thought about it. But that completely changes the landscape of discourse for personal identity. And actually, I think favors by default something like empty individualism, which is the idea that we are just a time slice, a moment of experience. In particular, Mike Johnson also had said this probably when we met like 2016 at some point, where he was thinking in also like the temporal boundary. And essentially he was thinking like, probably experiences are some kind of like 4D object in the block time universe. He didn't have like any particular mechanism of action or how that would be causally significant or anything of the sort. But he was thinking in terms of, 4D objects. And so, the temporal boundary actually would be, how are you not only, why is it like that you're not only divided from the rest of the universe, spatially, but also temporally, right? Like, why are you not the same experience over time? Why are you not just one huge experience for all of your life? Why are you like this experience after experience after experience? And how thick are they in the time axis? Speaking for myself, my intuition is that, each moment of experience is probably in the order of like a millisecond or something like that. Could be a lot smaller, but I don't think it's longer. I don't think it's longer than just 1 millisecond. I think that would be very difficult to pull off. Maybe 10 milliseconds at most. But after that, for reasons very deep, I'm not going to go into right now. Okay, so I will say now that we then in section 4, so section 3 is essentially, precise statements of the 5 specific subproblems of the boundary problem. Section 4 is about how the topological segmentation of the electromagnetic fields could satisfy these problems. Or essentially, actually it could satisfy this explainenda, or like frame-invariance, no strong emergence, non-epiphenomenalism, weak emergence. And the answer is it satisfies all of them. So to give you a taste of it, Whiskey 2011 essentially shows that most magnetic flux field lines occur in closed loops. So most of magnetism actually is topologically closed typically. It's not always, but the vast majority of it. In the case of the electric field lines, sometimes you actually get closed loops and sometimes you have like open loops, open lines, and that depends. And Irvin and Baumeister 2008 essentially show that you can actually make light knots. Like in the vacuum, you can actually have essentially these like twisted toroidal structures that carry light in a topologically structured way. Actually the topology of the electromagnetic field, even in the vacuum, can have these interesting topological properties. Now, there is something, this is a deep topic, but it has to do with the linearity of differential equations. I mean, it turns out Maxwell's equations in the vacuum actually entail linearity, meaning that, any combination of waves in the vacuum essentially can be added together and it will follow the superposition principle. So given that, the topology of the field in the vacuum may actually not have that many on its own causal significance. However, the moment it actually starts interacting with matter, it does become causally significant, because when you have these kind of like toroidal topological pockets, that can actually, for example, confine particles. An electron may actually be stuck, moving in this fashion. It's kind of like in a particle accelerator. Like the structure of the magnetic field lines is like trapping a particle and just can't escape it. It's essentially like that. So that is causally significant. I'll say one more thing about that in a second. Also, field topologies are hard boundaries. There's like a precise, spatiotemporal location where, for example, the field lines, rather than being like these like open lines, all of a sudden, whoop, they're actually a loop. And if you follow the lines, you're like eternally trapped in there, and then like elsewhere in space-time, they actually like open up again. And so there's like a 4-dimensional topological pocket and hard boundaries. And this is frame-invariant. I mean, like, of course, how you're going to visualize the field will depend on, how fast you're moving and how you measure it. but only in terms of your present measurements. The moment you actually integrate it over time, you will reconstruct the same topology. Why? Very beautiful technical reason, which is that according to special relativity, the thing that makes something frame invariant is that it is Lorentz invariant. Essentially, that the Lorentz transform leaves that mathematical feature intact. And it turns out topology is not modified by the Lorentz transform. I mean, the Lorentz transform is just essentially, squeezing and shearing and kind of doing this hyperbolic transform on the field, but is not changing the topology. It's not cutting or gluing at all, ever, right? So, boom, electromagnetic topology is frame invariant. It doesn't matter. It's relativistic. Then holism, like how do you get like this non-epiphenomenalism? Why was electromagnetic topology recruited by natural selection? The reason here would be that among many, there's many reasons, but one of the reasons is that when you have a topologically segmented out regions of the electromagnetic field, then electromagnetic waves inside it essentially highlight its resonant modes. In other words, it is very similar to why, for example, the sound of a guitar is an expression of the entire shape of the guitar. If you change the shape of the guitar, you will change the sound. And in some sense, you can derive, if you have enough data points, essentially what the shape is just based on the sound. Likewise, when you have, this electromagnetic pocket and there's, electromagnetic waves inside it that, for example, with total internal reflection, for example, in an optical network, then you will have standing wave patterns, essentially the eigenmodes, electromagnetic eigenmodes inside it, which are all of the ways in which you can fit a wave an integer number of times within that pocket. And that is going to be an expression of the entirety of the shape. And essentially, if you can measure these resonant modes, you can, up to a point, I think they're counterexamples, but like largely up to a point, rederive what the shape must have been. And therefore, because it acts as a unit, it is something that evolution can use for causal effects and for compute. And also, topology, this is a fascinating, very, fortuitous and very, very good coincidence, is that, the topology of the electromagnetic field is implied by Maxwell's equation. Well, Maxwell's equation, together with especially nonlinearities that arise in various materials. But essentially, that is also just standard physics. So we're not introducing anything exotic. This is just plain textbook electromagnetism. It's nothing fancy. Even though in most electromagnetism courses, introductory courses, they're not going to be telling you that, the topology can be non-trivial. Usually you're not going to be learning that until later, or like a seminar, or, looking at the cutting edge research that is happening nowadays. Well, so, that satisfies the desiderata. And let me actually give you like three very kind of like quick examples for how all of this comes together into causally efficacious topological segments of the electromagnetic field. Well, as I was saying, you have like, for example, in an optical network with, for example, fiber optics, you can trap light with total internal reflection, right? Like when you have something with a very high index of refraction, a material, and you have light that hits it at an angle, at a sufficiently acute angle, it doesn't refract, like the light doesn't actually go through to the other medium. There's a precise moment where actually it just 100% reflects, right? So that's called total internal reflection. And you can have like essentially a tube of fiber optics where you have total internal reflection, and then you will have, well, it's not going to be 100%, it's like going to be very close to it, but essentially for a while, you're going to have trapped electromagnetic resonant modes inside that. Now, here's a very amazing thing with a twist, literally and figuratively. If you take kind of like a band of a fiber optic, not a cable, but like, kind of like a surface, like a band, like a strip, and you connect it like a Mobius strip, then actually you will have like new exotic resonant modes. Like the actual topology of the fiber optic has a holistic effect on what kind of resonant modes are present within the region of total internal reflection. So again, this is, causally significant. Topology having like very causally significant effects. Second is, skyrmion bundles, which are essentially, these very interesting configurations of the electromagnetic field at the microscopic level that occur in some materials, where essentially, you get these like topological pockets. And they're used for compute. I mean, they can be used for compute. People are speculating how to do that. And because they can essentially endure over time. It's a way of encoding information in the field, not in its curvature per se, but in its topological defects, which can, carry over long distances. You may potentially be able to, like propagate them across a very noisy machine, and like the topology will be invariant. And third, solar flares and coronal mass ejections. I mean, like somebody might be very skeptical and say, okay, yeah, sure, I believe that topology matters, but like maybe it just matters in a very, very tiny esoteric, only in a lab, as you were saying, with a Mobius strip of a, a fiber optic or something like that. But no. The electromagnetic topology actually has enormous effects at a macroscopic level. I mean, essentially, if you look at a high resolution picture of the sun or videos, I highly recommend doing that. You will see these plasma tubes that go in and out of the sun. Well, that is electromagnetic confinement. These plasma tubes essentially are confined by the topology of the field. Now, what happens is that the sun is constantly spinning, and there's convection currents, and all of that essentially is transforming thermodynamic energy into helicity of the field. Essentially, the sun continues to get more twisted, more and more twisted everywhere, constantly, all the time. It's getting tense and stressed. And so every once in a while, it actually needs to release that stress. If it didn't, the sun would actually be torn apart by its own, like tension in the electromagnetic field. But every once in a while, you have kind of these like plasma tubes get very twisted, and at some points they touch each other, and what happens is called magnetic reconnection. When that happens, boom, essentially you get the plasma tubes can open up, and you have these millions of tons of matter just like sprayed into outer space with enormous energy. So that is a case where very huge, things that are larger than our whole planet, like these things are enormous. Topological changes at that scale in the field having enormous causal effects, like, for example, disrupting our power grid, sending these massive bursts of gamma rays into outer space. So don't be deceived into thinking that the topology of the electromagnetic field is like a very niche, kind of like laboratory only phenomena. Like, no, it's everywhere. It is routine. It is commonplace. Okay, so just to kind of finish out here. Okay, so like how does our solution essentially address the various sub problems? Well, first of all, the hard boundary, that's kind of like the whole point. I will say, though, that we are actually agnostic about like the deeper reality of physics. Some physicists actually might criticize electromagnetic theories of consciousness as just not fundamental enough. Fair, because what is truly fundamental is the quantum fields, and they're not spatial fields. I mean, they're like very weird mathematical objects. Like, if you look into quantum field theory, they're not describing a 3D space or amplitudes in a 3D space. They're describing essentially these like infinitely dimensional Hilbert space, which is in configuration space, where every point in that space corresponds to a possible configuration of all of the particles in the universe at once. And then you have things like electron fields, which are operator valued. It's not only that every point in the spacetime of an electron field is actually an amplitude, is more kind of like a matrix that is encoding an operator for Hilbert space. Like, to interpret that mathematical object and from that get our 3D spatial world is very non-trivial. Kind of an open question, actually. It can be done for like extremely tiny systems, but the level of the universe is just this mathematical nightmare, essentially. Arguably, that is the deep truth, right? So, okay, maybe the macroscopic 3D electromagnetic field is kind of like a shadow of that deeper reality. That said, we argued in the paper that nonetheless, even if the electromagnetic field is not fundamental per se, it can still do interesting things, like, for example, work as a kind of a waveguide or as a way of confining information transfer or possible interactions at the quantum level. So I actually suspect, I personally think it's quite likely that we will empirically verify the electromagnetic theory of consciousness with the topological solution, and maybe that it will be well established in science, but like it will still be a little bit mysterious, like in what way that is fundamental reality. But yeah, I'm fine with that. We're still making progress. 2 and 3, which is like lower bound and upper bound. Well, actually here we would say that no, actually there are all sorts of topological pockets everywhere around us and within us. Maybe actually a lot of the cells in your body actually do have a topological boundary around them. So like you might legitimately say that they are their own, experiences. Especially, yeah, if they're like dipoles, they're like oscillating very quickly. The magnetic field lines will be like first doing like this and then doing like this. And every time they flip, there would be like a different moment of experience. Again, like a boundary over time. There's like 20 quadrillion ants on Earth. Just the fact that it's kind of hard to imagine that there are like a lot of a particular thing doesn't mean that that's not the case. So yeah, I think it's likely that we will actually end up like finding out that, yeah, the universe is actually being with huge number of topologically closed pockets, moments of experience. What are you going to do? Well, actually, hedonic calculus would suggest that then, yeah, actually our biggest responsibility and mission in this universe will be to actually increase the welfare of the topological pockets of the world around us. Yeah, huge task, but I don't know. You've got to commit to something. Number 4, which is, yeah, the private boundary problem. Well, yeah, physical proximity and essentially sharing the segmentation mechanism is going to be a constraint. Like, yeah, if you actually have electromagnetic resonant modes in the brain, they require this very high degree of actual physical connectivity and synapses in order to be self-sustaining. And likewise, yeah, like their field strength decays very quickly outside of you. That said, potentially, if you were to, for example, hook up my thalamus and your thalamus with a neural bridge, and actually share kind of like the lowest shared frequency of resonance, and that is actually the mechanism of topological segmentation, then actually, yeah, it might very well be that you and I can become one subject of experience, no problem. And then number 5 is essentially the temporal boundary. Well, there actually we reference the concept of a pseudo-time arrow, which is a concept I developed to explain the feeling of the passage of time, phenomenal time. And I've written a lot about it. I have presentations as well online. But yeah, essentially the idea is that the feeling of the passage of time is something that is actually contained within each moment of experience. It has to do with how is each moment of experience actually structured internally. Is a thing that determines whether it feels like time is moving very fast or slow, or even weirder, whether it feels like time completely stopped, as sometimes it happens in so-called moments of eternity, or the time is looping, for example. Or like, yeah, we call that exotic phenomenal time. It happens on meditation, in psychedelics, in spontaneous, mystical experiences, in near-death experiences. So yeah, the normal flow of time is a special case of a much more general thing. And for me, that just means, not just, but it does mean that phenomenal time and physical time are different things. Essentially, physical time is more about like entropy and the arrow of time in physics, whereas phenomenal time is like how is each of these topological pockets is structured. And in fact, yeah, in this view, if you have this like lowest resonant mode of the entire brain, that maybe is the thing that kind of like helps unify all of your brain, essentially doing this electric dipole may, for example, generate a magnetic flux first in this direction and then in this direction, and every time it flips, bam, that's a boundary. And so, actually temporal boundaries would be something along those lines. It's like, yeah, whoop, whoop, moment of experience, moment of experience, moment of experience, moment of experience, and so on and so forth. With a nested structure, and as long as the magnetic flux lines are actually all interconnected so that you can go from anywhere to anywhere within that flux, then yeah, all of that will be a topologically closed pocket. Yeah, so I mean, essentially, yeah, just to conclude, we think that this tentative solution satisfies all of the criteria, definitely all of the criteria we laid out. We encourage other theorists, other people in this field, in this field of consciousness, but also in this research field, to essentially, yeah, use kind of, the various constraints that we proposed, as well as the various ways of carving the boundary problem into 5 sub-problems. We encourage them enthusiastically to try to bounce their own theories against this framework. Because I think with that kind of framework is how you advance science, by getting common agreement on what is it that the theory must be able to explain. And yeah, and I think ours, satisfies it. The trickiest part, actually, I think, is going to be like how fundamental the electromagnetic field is. But again, our theory makes predictions, and I think we can empirically probe it. And maybe in 10 years, we will be able to publish a paper and say, the solution to the boundary problem was correct because we doubly dissociated, cognition from consciousness, or things like that. And the thing that essentially carries consciousness is the topological pocket. So, yeah, that's about it. I mean, the paper actually goes into more detail, and I do highly recommend reading it in its entirety. You will learn a lot. You will get very much up to speed with the conversations in the literature, and you will understand, why what we are saying is new, meaningful, and non-trivial as a contribution to the field of consciousness and the field of the study of consciousness. So with that, thank you so much for joining. And again, none of this could be happening without, supporters, everybody who's been in this path, all the way from kind of like David Pierce and the Stanford transhumanist days to co-founding with Mike and Romeo, and then interns in 2019 and 2020, and more recently, amazing people like Hunter and Crystal and Maggie and Anders and and Marcin and our donors. Thank you so much. It means the world. I'm extremely grateful. So, infinite bliss, everybody, and let's continue moving on. Ciao, everybody. Take care.